Hello everyone, welcome to another class. Today we have this math challenge for us here. If I want you to watch me solve and verify the value of m here. And from this question, we discovered that the power of m is 3. In other words, we have to solve for 3 roots to this challenge here. So I want you to sit back and watch me solve for all 3 roots and also verify these 3 roots in a clear format. So let's take our solution here. So we have here solution. All right. So the interesting part is where we're going to substitute all 3 roots into the original equation, including the imaginary root. So watch from the beginning to the end of this class. It's promising to be fun. So yeah, look at the question we have here. So the number one thing is to move this expression to this side of the equation, which is the quantity on the right hand side to the left hand side. So this is going to give us our m to the power of 3, then minus 5 to the power of 3. This is equal to 0. So what you see there is simple. This is what we call difference of cube. And what does it say? It says that if you have your x to the power of 3 minus your y to the power of 3, this is equal to bracket open your x minus your y close bracket your x squared, then plus your xy, then plus your y squared. Remember this is what we call difference of 2 cubes. Okay, so with this difference of 2 cubes here, what we do, we can rewrite this left-hand side of this expression. And so this is going to give us bracket open our m minus our 5 close bracket open our m to the power of 2, then plus our 5m, then plus our 5 to the power of 2 close bracket. This is equal to 0. Easy, right? Good. So what we do here now is very simple. Here we apply the zero product rule, which says that if you have your x times our y equal to 0, it implies that our x is equal to 0 or y equal to 0. You remember this also? Okay, this is what we call the zero product rule. So in other words, we have to equate this to 0, equate this to 0. Easy. So this will now give us case 1. We have our case 1 to this challenge here. We have our m minus 5 equal to 0. So we now have m equal to 5. So this is the first root. This is the only root that many people looked at, okay? But from here, we discover that our m equal to 5 is a real solution. All right, so let's go ahead and take our case 2 here. So our case 2, we have here case 2, and see what case 2 will give us. I guess case 2 will give us 2 imaginary roots here. So this is going to give us here our m to the power of 2, then plus our 5m, then plus our 25, because 5 to the power of 2 will give us 25, right? Okay, so we roughly have here now, this is a quadratic equation. So how do we solve this quadratic equation? We're going to solve this quadratic equation using what we call the formula method, right? So let's continue on this side of the equation here and see what this gives us in time. So we're going to have our formula m is equal to minus b plus minus the square root of our b squared minus 4ac, everything all over 2a. So what is our a? A is equal to 1, which is the coefficient of our m squared, and our b is equal to 5. The coefficient of our m and our constant term c is equal to 25. So let's go ahead and substitute here. So we're going to have our m is equal to, here we have minus 5 plus minus the square root of our 5 squared, then minus 4 into 1 into 25. Those brackets, right? Let's cover this word all over our 2 into 1. Good. So if we proceed further, this is going to give us minus 5 plus minus the square root of our 25, then minus 4 times 1 is 4 times 25, that will give us 100. So we have 100, all right, everything all over our 2 here. This is equal to, so we have minus 5, the plus minus the square root of 25 minus 100 will give us minus our 75. They all over 2. Now 75 can be expressed as our 3 times 25. And here we have a minus sign. So we can rewrite the whole of this expression as our minus 5 plus minus the square root of minus 1 times the square root of 3 times the square root of 25. Yeah, all over our 2. Yeah. Now recall that the square root of minus 1 is equals to what? Iota. So if we have the square root of minus 1 to be iota, then we can bring that here. And the square root of 25 is 5. So rewriting the whole of this expression, this is going to give us something like this. Minus 5 plus minus, yeah, our 5 iota into the square root of 3 all over R2. So you now see we have two solutions to this. So we're going to have our M1 is equal to minus 5 plus our 5 iota to the square root of 3 all over 2. And our M2, okay, this is going to be M3 rather. So this is M2. This is our M2, please. And this is our M3 will now give us here our minus 5 iota into the square root of 3 all over 2. Okay, so we want to verify these two answers here now. All right? Because also this number 1, we want to check if these 3 roots will satisfy the original equation. That is the essence of this video. So let's go ahead and verify. So we continue on this side of the bird. Again, let's roll off and see what this gives us. Okay. Now, we want to take the first one, which is our first answer here. We have m is equals to 5. So we have here check. So we have our question to be m to the power of 3 equals to 5 to the power of 3. So for m equals to, we have our m1 equals to 5. We just have to put 5 here. So we have here 5 to the power of 3 is equals to 5 to the power of 3. And what is 5 to the power of 3? But we don't need to do that because here we have 5 to the power of 3 on the right-hand side, and on the left-hand side we have 5 to the power of 3, which is 125 equal to 125. So this shows that the first root, which is this very word, satisfy the original equation. All right, so let's check for the second root, m2, which is this. So when m, so we have here when our m2 is equal to minus 5 there plus our 5 iota into root 3 all over 2. So the question again, we have m to the power of 3 is equal to our 5 to the power of 3. So let's bring in our quantity in there. So this is going to give us here our minus 5 plus 5 iota into root 3 all over 2 all to the power of 3. Then this is equal to 5 to the power of 3. This is where the work lies here. Okay, so what we do, we just have to rewrite this expression we have here now. The whole of this expression could be written as our bracket minus 5 all over 2, then plus 5 iota into root 3 all over 2, close bracket, all to the power of 3. This is equals to 5 to the power of 3. We are not out of context, right? Good. So we want to use the binomial expansion to expand this, okay? And again, using the Pascal triangle to get our coefficient to the column for the third power. We know from Pascal triangle, we know that the power of 0 will give us coefficient of 1. The power of 1 will give us coefficient of 1, 1. The power of 2 will give us coefficient of 1 here. Then add these two to give us 2. Then we have 1. Then the power of 3 will give us 1. Then add this 1 to this 2 will give us 3. 2 to this one will give us 3. Then this other side we have this. So we are considering the third column here. Okay, so these are the coefficients. right? And again, there's something we want to also spot out here again, because we are having iota here, and we must get the value of iota to the power of 3. So we know too that the value of iota to the power of 0, this is equal to what? 1. Because anything to the power of 0 will give us 1. Then iota to the power of 2 will give us minus 1. And iota to the power of 3 will give us minus iota. So we are going to make use of this also. So let's keep this aside, because we're going to make use of this and this in solving for the value of these expression we have here now. Okay, so let's continue on this side of the board. Again, we want to expound this now using these expressions we have here now. So the first term from here is going to give us our minus 5 all over 2 all to the power of 3. Then this quantity we take to the power of 0. And anything to the power of 0 will give us 1. So this quantity will not exist, right? So there we have here plus. For the second term, look at the coefficient. The coefficient is 3, so we're going to have here 3 into, then this first quantity is going to take the power of 2. Okay? We know that this power will be decreasing, while this power will be what? Increasing. So it was formerly 0. Here it's going to talk to 1. So times bracket our 5 iota all over 2 all to the power of 1. Whether you put the 1 there or not, it doesn't mean anything. Then we have here the plus again. Again, this will now decrease to 1. So we have here, again, look at our coefficient here. We must put that coefficient there, bracket our minus 5 all over 2 all to the power of 1. And meanwhile, this will now increase to the power of 2. So 5 iota all over 2, right? Oh, pardon, I didn't put the square root here. Here we have square root of 3. Sorry, so I have square root of 3. Then here we have the square root of 3. All right, the close bracket, and this will increase to 2. Then plus this will now turn to the power of 0, which is 1. So it will leave the system, leaving this alone. So we'll now have this to be our 5 here, right? Isn't that so? Yeah, we have 5 I, then into the square root of 3, then into our 2, all to the power of 3. Okay, so let's go ahead and, open up everything here. So what is minus 5 to the power of 3? That is our minus, this will give us minus 1, 2, 5, right? Good. All over 8. Then we come to this side, plus minus 5 to the power of 2 will give us 25. And so 3 times 25 will give us 75 all over, here we're going to have here 4 times, here we have 5 iota. So let's keep the 5 here, iota root 3 all over 2. Okay, then we come to this side. This minus here will affect this plus here, right? So this is going to give us, but let's deal with what we have here, because here we're going to have the square root of iota, which is going to give us minus 1. Look at it here. Okay, so automatically, let's just keep this up first. So we have here minus our 15 all over 2. Then, yeah, we're going to have times 5 to the power of 2 will give us 25, right? Then times iota to the power of 2 will give us minus 1. Let's keep this minus 1 here. Okay? Then these 2 will take care of this radical. So times our 3, everything all over 2 to the power of 2 will give us here 4 here. Then we come to this other side. We have here plus, what is 5 to the power of 3? That will still give us 125. So we have here 1, 2, 5. Then what is iota to the power of 3? Look at it here. We have it to be minus I. So let's put in here times minus I. Let's put this in bracket. Then we come to this side now. What is root 3 to the power of 3? That is root 3 times root 3 times root 3, which is automatically 3 root 3. So we're going to have here 3 root 3, then everything all over, what is 2 to the power of 3? That is 8. Mind you, everything is equal to 5 to the power of 3. Okay. All right, we're almost there. Then we proceed again. We cannot multiply out all this quantity we have here. So we have here minus our 1, 2, 5 all over 8. Then this will give us here plus, what is 75 times 5 iota? This will give us 3, okay, 75, right? 375. The iota root, our 3 here, all over 4 times 2 will give us 8 here. Then this minus we cancel out this minus to give us here plus. So we now have 15 times 25 times 3. And what will that give us? That will give us 112, right? Yeah, it will give us 1125. 1125. So we're going to have here 1125, right? Okay. Because here we have minus 1. So this leaves the system. All over here we have 8. Then we come to this side. This minus, we times this plus to give us here minus 125 times 3. That will give us 375 again. Okay, because this time this will give us our 5. Then this time this will give us 6 plus the one you carry 5, 7. Then 3 times 3 will give us this, the iota root 3 all over our 8 equal to 5 to the power of 3. Okay, so let's look at it. If you check this now, you discover that we're having plus 375 iota root 3 all over 8. Then we have minus 375 iota root 3 all over 8. So this will go with this. So we can now bring this and this together. So we now have here minus 1, 2, 5 all over 8. Then plus 1, 1, 2, 5 all over 8 equal to 5 to the power of 3. We're almost there, like I said. Okay, so they have a common denominator, so we can add the numerator. So we now have this now implies that our minus 1, 2, 5, then plus 1, 1, 2, 5 all over 8. Yeah, this is equal to 5 to the power of 3. If you subtract this, it's going to give you 1,000. 1,000 all over 8 equals to 5 to the power of 3. So let's continue and see. This will give us something reasonable. So if we use this to divide this, what would this give us? This is going to give us 1, 2, 5, which is equals to 5 to the power of 3. And what is 5 to the power of 3 is 1, 2, 5. So this shows that our answer, which is the second root, which is m, where's our second root? Okay, we've erased it, but our second root is this. Our minus 5 plus 5 iota root 3 all over 2 also satisfy the original equation. So now we are left with m to the power, m3 rather. So to check if this satisfies the original equation, I've done that too. So you on your own, do this on your own and see if it will also satisfy the equation. So, but in all, we now have the first answer, which is m1 is equals to 5. 5 satisfies the original equation, and our m2, which is equal to, we have our minus 5, then plus 5 iota root 3 all over 2 also satisfy the original equation. Okay, so these two satisfy the original equation. Remaining this one. Okay, so on your own, you can confirm if this also satisfies the original equation. The rhetorical, but at least we'll be able to solve and also check for the authenticity of this root. So if you learned something from this video tutorial, give the video a thumbs up. And if you're not clear in any of these steps analyzed here, drop it in the comment section. We are there to reply to your comment. Thanks for being there. This is Online Maths TV. Remember, we love you and keep winning until we see you in our next class. Bye for now.